All right, now for a two-sample independent means t-test, meaning that we have two groups, they're independent of one another, and we want to see if there is a significant difference between them. So in this example, again, this is just simulated data, so it doesn't really mean anything, and there's two groups in the data, it's group A and group B. Our null hypothesis here is that they're different, so we're asking, do they have a significantly different score? Do seniors have a significantly different score than freshmen? Meaning our null hypothesis would be no, they're exactly the same, and our alternative hypothesis would be that they're different. To run this test, we're going to be back in SPSS. Remember, you need to upload your data to the virtual lab before you can find it in SPSS, but once you have it open, it's a good idea when we're working with groups to pop over here in variable view. You see this is our group variable values, and here I've coded A as seniors and B as freshmen. If you do that, then it's going to make your interpretation later on a lot easier because you're not dealing with these abstract values. All right, to run the test, we're going to go back to compare means and proportions. This is where we're going to be for all of our t-tests. Then we're going to look at independent samples t-tests. This one looks pretty much similar to the one sample t-test, except now we have a grouping variable. Our test variable is score. We're going to move that over here, and we're going to put our grouping variable in grouping variable. You'll see these two question marks here. That's because we need to tell SPSS what our groups are. Now, you might think at first you want to put in some abbreviation to say, who they are. No, you need to put in the values that are in the grouping variable. So in this case, we have A and B. So we're going to say group 1 is A and group 2 is B. Continue, and you'll see A and B populate there. Again, effect size, click OK, and now we have the results. Again, just like before, our summary statistics are up at top. This is where, by adding this information and values, we're able to see on our table very clearly which group is which, because it'll add those labels here. We can see that our sample sizes were almost the same, but a little bit different, with seniors having a mean of 76 and freshmen having a mean of 80. So that's probably not super accurate, we hope. Our standard deviation, our standard error of the mean. Independent samples t-tests are going to look a little bit different than our one samples t-test because we have the Levene's test for equality of variances that we have to look at first. So one of our assumptions with t-tests is that our group have equal variances. SPSS runs this test automatically, and based on the results here, it determines which row you're going to look at to the right. So right here where independent samples t-test is, draw a line there and know that this is Levene's test and the rest of this are two different t-tests. If the equal variances is assumed, then the significance value here will be greater than 0.05. It's just like a p-value anywhere else, except in this case, we're hoping that the variances are going to be equal. And so we're looking for a significance, or we're looking for a p-value here that is not significant, i.e. greater than 0.05. In this case, 0.5 is great. That means that the variance between these two groups is the same. And we can use this top row for the t-test. If the significance value was, say, 0.001, then your variances are not the same, and SPSS automatically applies a correction, which is why then we can use this second row. But again, in this case, since we're at 0.53, they're not significantly different, so now we can move past that to the independent samples t-test and look at the top row of this table. Our t-test is negative 0.748. Our degrees of freedom are one-sided and two-sided p-values. Now, in this case, we said, are they different? So just are seniors different from freshmen? We didn't specify a direction. So in that case, we're just looking at two-sided. Either side, we just want to know if it's different. If we were to change this and say, less than or equal here, or if we say if seniors have significant higher scores than freshmen, then we're going to have some amount of directionality, and we're going to want to use the one-sided p-value. Then the sign over here of our t-test, so if we change to this, and we want to know if seniors have higher scores, then we see the one-sided is not significant, so they're not significantly higher. If they were significant, then we would look at the t-statistic, and since it was negative, that would actually be telling us that the seniors are significantly lower than the freshmen. In this case, we're not significantly different here, which answers this question. And then if we put back to our original of, are they just different? Don't care about the sides. Then we're looking at the two-sided p-value at 0.4. They're not significantly different. So freshmen and sophomores, although seniors had a slightly lower score than freshmen, are scoring, there's no significant difference between their scores. And just like before here, now we have the mean difference. This time, instead of the difference compared to the one sample t-test where we were just looking at the difference between the sample mean and the population mean, here the mean difference between these two groups is negative 0.39, meaning that since seniors are our first group, on average seniors scored less than 0.39 than freshmen. However, again, since this is not significant, we wouldn't make that claim. Standard error, our confidence intervals, and our effect sizes just as before. There you go. That is an independent samples t-test. And next we're going to look at the dependent samples.